So with that, I'd like to introduce the speaker of today's webinar, Laura Dubreuil from Neuroelectrics. Laura is a member of the Boston Neuroelectric team, and she's leading our US technical department. Her main research interests focus on the multifocal transcranial electrical stimulation and practical aspects of tES, including simultaneous tES with EEG and event-related potential recordings, tES applications in ADHD, and deep learning for the neurological diagnosis. So Laura, the floor is yours.
Thank you very much, Rafael, and thank you everyone for attending this webinar in these challenging times. So as Rafael said, today I would like to introduce you to Starstim, one of our main products at Neuroelectrics for tES and EEG research. So first of all, I'm going to start by giving a little bit of introduction about who we are as a company and what clinical trials we are currently performing. Then I'm gonna explain why there is actually a need to perform concurrent tES and EEG experiments, and I'll show you a little bit the solutions that we have designed, both in terms of hardware and software. I'm also going to recommend some resources and publications to get into more details, and finally we'll open the Q&A session so that you can ask me some questions. So Neuroelectrics is a company at the intersection of neuroscience, engineering, and artificial intelligence that provides personalized technologies that can measure and modify brain function through EEG recording and transcranial electrical stimulation, with the goal of developing research and clinical applications for a wide range of diseases, for example, for epilepsy, for neuropathic pain, dementia, depression, or ADHD. Some facts about our company. Our technologies have been used in more than 100 scientific publications. We are currently selling in more than 45 countries around the world. We have been doing research in the neuroscience field for more than 8 years, and we are present both in Europe and the US through our offices in Barcelona and Boston, respectively. And although most of our clients are using our devices for research applications, on the clinical side, we are currently performing a number of clinical trials in different and a wide range of diseases, including epilepsy, Alzheimer's disease, chronic pain, depression, cognitive aging, and neuropsychiatric disorders. If you are interested in learning more about these clinical trials, feel free to visit our website, neuroelectrics.com, neuroscience/research applications. So you may be wondering why there is actually a need to combine tES and EEG research. For example, on the basic research side, the high temporal resolution of the EEG offers a great opportunity to understand the mechanisms of tES with experiments, for example, using event-related potentials or connectivity metrics, for example. On the clinical side, the combination of EEG can be used to find biomarkers for specific diseases, for example, to diagnose epileptic seizures and then use tES to treat them. For example, we are also using this combination of EEG and tES in one of our clinical studies in which it's called STIPET. And we are using EEG to kind of find biomarkers for ADHDs and tES to try to find a treatment for ADHD and autism. EEG can also be used to quantify and predict the efficacy of tES by providing a biomarker that allows for stratification of patients before intervention. The combination of EEG and tES also allows for more complex applications like closed-loop system, for example, where the EEG is used as a feedback to better optimize the tES parameters in real time. So with that in mind, we have designed a device called Starstim, which is a hybrid system that allows for EEG recording and transcranial current stimulation with 3 different versions, with 8, 20, and 32 channels. And one of the key features of this device is that you can do both. You can do standard bipolar montages with 2 electrodes, and you can also do multi-channel montages with up to 32 electrodes that allow for more focal stimulation. So more specifically, Starstim is a wireless device. It's a portable device powered by rechargeable batteries that can last up to 5 hours. It is also designed to be easy and fast to set up with different cup sizes that can fit children and adults. On the stimulation side, it allows for direct, alternating, or random noise current stimulation with the possibility of using custom waveforms for bipolar or multi-channel montages with up to 32 channels. You can also configure multi-step protocols in which, for example, you can record EEG before, then you can stimulate for 20 or 30 minutes, and then you can record EEG again so that you can compare any changes happening before and after the stimulation. Or you can also record EEG and apply stimulation simultaneously. The device also comes with a software that provides modeling of the electric field created by your specific montage and real-time visualization of the EEG signals. On the electrode side, Starstim can be used with different types of electrodes depending on whether they are meant to be used for EEG or for stimulation or for both. So on the EEG side, we provide the standard wear electrodes that are used with gel. Then we also provide dry electrodes that are made of silver to silver chloride, and they do not require any gel. And then we also provide what we call solid gel electrodes, which are semi-dry electrodes that provide kind of a good trade-off between good quality and comfortability. On the stimulation side, we also provide the sponge electrodes that come in different sizes, and they are mostly used for bipolar montages. And the star component of our electrodes are the NG PyStim electrodes, or next generation PyStim, which allow for both EEG recording and TES stimulation with multi-channel air and bipolar montages. If you want to learn more about our electrodes, you can visit our website and you will learn more about it. So in terms of features and specifications, the only difference between the three versions of a Starstim 8, 20, and 32 channels is the number of channels, which basically determines how much focal you can be in your stimulation and whether you can do complex network stimulation protocols and closed loop applications. But all the other specifications remain exactly the same. So far, all the products that I have presented are mostly thought to be used in a hospital or in a lab environment. However, we also offer a home version of a Starstim, which allows the doctor or the researcher to schedule a series of stimulation and EEG sessions that the patient can perform at home. So basically, the idea is that the doctor will provide the patient with a Starstim device and a tablet with a software that will guide the patient through all the setup process and all the stimulation process. And at the same time, the doctor or the researcher will be able to configure and manage the stimulation sessions remotely through a cloud platform that is connected with the tablet. Another key feature of a Starstim is that it can be used together with MRI and NIRS technologies by adding some accessories. So, for example, in the case of MRI, you just need the MRI filters, the MRI compatible electrodes, and the extension cables that will allow you to place the device outside of the MRI room to perform the stimulation safely. In the case of NIRS, Starstim has been integrated with a NIRS device provided by our partner Artinis, who can also provide you with further information. So here comes the fun part. So I'm gonna play a video now on how to set up a Starstim for you, just to get a better idea of how it looks like. But I have included this link here just in case there are any issues while playing the video online. So, okay, let me share the other screen. Okay, I think you can see it now. Okay, so let me play that. Okay, so the first step in the process is to prepare the head cap and the electrodes by placing them in the desired positions where you want to record EEG or stimulate. The next step is to place the cap on the patient's head or the subject's head, ensuring that the CZ position is in the midpoint from ear to ear, as shown in the video. Next, we inject gel into each electrode, and then we make sure to move the hair away and screw the top part of the electrode into the bottom part. Then we clip the cables onto the electrodes, making sure to match the electrode label with the right position in the head cap. Then we put a little bit of gel in the ear clip. We connect the CMS and the RL cables, and we place them in the earlobe, which will be used as a reference of the device for both EEG and stimulation. We finally attach the device to the Velcro in the back of the cap. And we connect each electrode set to each corresponding slot, which are labeled from 1 to 4. So note that in the case of a Starstim 20 and 32, there are 4 slots for each cable, and then there is a 5th slot for the reference. Finally, we switch on the device and we are ready to connect to the software. Okay, so I'm gonna go back to the presentation. Okay, so as a summary of what I said, Starstim is a hybrid device that can apply TES stimulation as well as EEG recording. It comes in 3 different versions with 8, 20, and 32 channels with different cap sizes for adults and children. It connects wirelessly to the software with an optional USB cable connection. It has I didn't mention that, but it has a built-in accelerometer that allows you to track the movement artifacts in your EEG data. On the stimulation side, it allows for direct, alternating, and random noise stimulation, as well as EEG recording before, during, or after a stimulation. It also includes some safety features, such as 2 milliamp current limitation per electrode and continuous impedance monitoring. And finally, it is also compatible with the MRI and the NIRS technologies. If you want to learn more, I recommend you to check our website, the resources part, which contains many ebooks and different training materials for you to get into more details. So for the software, I'm going to do the same. I'm going to play this video so that you can see how you can interact and you can configure your protocols with the Starstim. So let me share the other video. Okay. Okay, so after setting up the device, the first step is to download the software from our website, neuroelectrics.com/downloads. Note that the NIC software can be used in both Windows and Mac systems, so you can choose the one that suits your best needs. Then once the software is installed, we launch it and we select the type of connection that we want to use, either Wi-Fi or USB cable. Then we connect the device, and once the device is connected, we create a new protocol. So here we basically, first we name the protocol, we name each step, stimulation or EEG. We can also set the duration of the stimulation, and then we select what electrode we want to use for EEG or for stimulation. Then we also can choose whether you want to use TDCS, TACS, or TRNS. And then, for example, we are going to use a basic protocol with 1 anode and 2 return electrodes or cathode electrodes, splitting 50% of the current through each of them. So you can configure that here by placing 50 through each of them. Then you can also configure the ramp up and the ramp down duration at the beginning and the end of the session. And if you want to do sham stimulation instead of real stimulation, you can also enable it and configure the fade in and fade out durations for both the beginning and the end of the session. So we finish and we save the protocol. And then we can also take a look at the modeling of the electric field created by this specific montage. In this example, we are injecting the current through C3 and collecting it through C4 and P4. We can also see this modeling through different angles, like the top, the bottom, the right, or the front. And we can also change the scale of colors to focus on some specific areas. Then we finally load the protocol. And we start, let me stop the video here. So we start by seeing the different EEG signals. You can also see that you can hide specific channels if you just want to focus on a specific subset of them. Then the next step, so when you select the EEG channels that you want to visualize, the next step is to perform an impedance check to make sure that there is good conductivity. So we basically wait for all the indicators to become green. And whenever this becomes green, we can start the stimulation by clicking on the play button here. So you will see that this bar here, this is a progress bar that whenever it reaches the end, it means that the protocol is finished. So the protocol starts, and this bar here is going to increase. So whenever the protocol is finished, we go to the home button, we disconnect the device. And then very important, we switch it off, and then we make sure to charge it for the next session. So we need to make sure that it's turned off and connected to the charger. And also very important, we need to wash our electrodes with water and soap, and you can also disinfect them if you want, and make sure to let them dry so that all the gel is removed. So let me go back to my presentation. Okay, so another important part of the stimulation protocol is to properly design the montage that you will use in terms of electrode positions and currents. And with the NIC software, you can visualize the electric field of your montage, as I showed before. But if you want to go one step further, you can also optimize the positions and the currents with the goal of maximally stimulating your target area. To do this, we offer a service called StimWeaver, by which you can provide us with the MRI template of your patient, and then we can create a personalized head model. And based on this head model, we can compute the optimal positions and currents to maximally stimulate that area. Or we can also compute the cortical mapping or the source localization for your EEG signals. I invite you to check our website to learn more about our modeling services. So as a summary of what I said about the software, the NIC software provides real-time EEG visualization as well as electric field modeling. You can input direct, alternating, and random noise currents, as well as custom waveforms such as pulse stimulation or other types of custom waveforms. You can enable the sham and the double blind modes for your clinical trials. I didn't mention this, but you can also use our platform called MATNIC, which is a set of MATLAB scripts that allow you to control the stimulation and the EEG parameters in real time for closed loop applications. You also have the option to go one step further and optimize your montages in terms of positions and currents using our StimWeaver service. And on the EEG side, I didn't show this in this specific video because we will go into more details in one of our next webinars, but you can also visualize the EEG spectrograms as well as the power distribution across the scalp map in real time. And you can also synchronize with external softwares for ERP experiments, for example. And you also have access to the raw EEG data in text and EDF formats. I would also like to invite you to take a look at our Wikipedia, where you will find a list of publications using a Starstim, as well as some interesting papers on electric field modeling and network stimulation. And finally, we have recently updated our website, and we have included a lot of educational resources, including ebooks, white papers, case studies, and training videos that I hope will provide you with some interesting insights for your research with the Starstim. Thank you so much for your attention.